Hello and welcome to Exponentials 3.1, Exponential and Logarithmic Graphs. Okay, so today I'm going to show you guys two graphs, and you're going to see the differences and similarities between the two. And hopefully it's going to not be too bad, but we'll see. I'll try to explain things in as much detail as I can. And if you have questions, just let me know in class. Okay? But the first thing I want you guys to focus in on for this first slide is the b value, or what we call the base value. Yeah, and the letter B is your base, and if it's a value greater than 1, so let's look at this first blue box on the top, then you're going to have a graph that indicates exponential growth, meaning it's going to go up to the right. And if you have a base value that is between 0 and 1, it's going to indicate exponential decay, meaning it's going to go down or get lower in value, I guess you could say, as it goes from left to right. Okay, so it might not make any sense as you guys hear me talk about it now, but when I start showing you guys the graphs in the next couple of slides, then hopefully it makes a little more sense at that point. But yeah, if you have questions, just don't hesitate to ask in class. Okay, but let's go. Let's start. Okay, so this first slide shows you an example of exponential growth. So as you can see from left to right, it's getting greater in value, so it's going up basically. And on the bottom, you have the left side of the graph approaching your horizontal asymptote at y equals 0, and you have your y-intercept at 0, 1. Okay, and the way we're going to do these graphs right now for this lesson is going to be through making tables. That's not the best way to do it, but it's probably the easiest one right now. So yeah, I guess you're trying to get you the feel of what the graph is going to look like, so that when you got to draw it yourself, then it's not going to be too bad, because at least you're going to know what the shape is going to look like and how it got that shape in the first place. Okay? Okay, and this next graph is going to be exponential decay. So as it goes from left to right, it's getting lower in value, but not so lower it goes below your horizontal asymptote though, right? You see that red dashed line, right? So it's going to get lower and lower and lower, but it's never going to get low enough where it's going to touch the horizontal asymptote. So there's going to be the difference in that situation. Okay. Okay. Oh, for our first problem, I'm going to show you guys how to get the table of values that we're going to eventually use to get this graph onto your paper. Okay. So when you graph these things, you're just going to use your standard values of x, -3 to +3, and you're just going to plug those 7 numbers in place of x, and when you get those calculations all figured out, then you're going to get your answer, okay? That you're going to use as your y value, so you can plot the coordinates x, y. But we're not going to plot it this time, but we're just going to show you guys how to make the table. Okay, so when I plug in -3, so let's move this little box on out of the way, you're going to replace the x with -3, so 5 to the -3 power. Yeah, 5 to the power of -3 rather. And that -3 is going to tell the 5, the negative part of the exponent is going to tell the 5 to go on the bottom. And, ooh, sorry, you can't really see that line that's supposed to be the fraction. So let me just draw it in. Okay, let's draw it in so that it doesn't hide anything else though. Okay. All right, and then the 125, that fraction's kind of gone too. Okay, so sorry about that. All right, so that negative tells the 5 to go on the bottom. And the power of 3 says you're not just going to put 1 5 on the bottom, you're going to put 3 5s on the bottom. So it's going to be 1 over 5 to the power of 3. Which when you multiply all that out, you're going to get 1 over 125. Okay? And then we're going to plug in -2 for x and do the exact same kind of computation. Yeah, so it's going to be 5 to the power of -2. The negative is going to tell that 5 to go on the bottom, right? And you're going to have 2 5s on the bottom because your power is 2. And then that's going to turn into 5 squared, which becomes 25, so 1 over 25. And you're going to see this pattern just repeat, right? We're just going to plug in -1 next, which is going to turn into 1/5. Then you're going to plug in 0, which hopefully you remember that any base value, doesn't matter if it's a fraction base value or a decimal base value, yeah, any base value to the power of 0 is going to be a value of 1. Okay? All right, and then you're going to plug in 1, and that's going to hopefully be not too bad. 5 to the power of 1 is 5. And then 5 to the power of 2 is 25. And 5 to the power of 3 is 125. So these numbers are going to be pretty much the standard ones you're going to use. And you're just going to plug them in just exactly how you saw me do it just now. Okay? So that's how to create the table. So I think the next problem is going to get into how you do both steps. Create the table and then plot the dots to get your graph. Okay, so this time we're going to be looking at a little bit different base value, which is a fraction. Last time it was just regular 5. This time we're going to work at the fraction base value of 1/3. Okay, and while that looks kind of intimidating, let's see what it does. Okay, so let's look at our first value that we're going to plug in, -3. So basically 1/3 to the power of -3, and that negative is going to do its thing. Yeah, but in this situation, it's not going to make something go to the bottom, because you're going to notice the 3 is already on the bottom because your base value is 1/3. So instead, it's going to make the 3 go to the top. And that's what negative exponents do. They pretty much either flip things around or tell things to go in the opposite location. So however you want to word it so that you understand it, that's what's going to happen. Okay, so the 1's going to go to the bottom, the 3 is going to go to the top, and 3 over 1 basically is known as 3. So 3 to the third power is basically what 1/3 to the -3 power is. It's 3 to the third, which then turns into 27. Okay? So if that didn't make any sense, hopefully it makes sense in round 2 when I plug in -2. Okay? So let's check out -2. So 1/3 to the power of -2. The negative says to the 1 and the 3, switch places, right? So 1 go to the bottom, 3 go to the top, right? That's what the negative power does. And the 2 is just going to be how many 3's you have, right? So when the 3 goes to the top, the 1 goes to the bottom, that's just basically 3. So that turns into 3 squared, which becomes 9. Yeah? And then when you plug in -1, same thing. Negative says to the 1, go to the bottom. Negative says to the 3, go to the top, which in essence is 3. So 3 to the power of 1 is 3. Okay? Then you're going to plug in 0, and like I said earlier, anything to the power of 0 is a 1. Then you're going to plug in 1. Okay, come on. All right, there you go. So you're going to plug in a 1, so you're going to get 1/3. You're going to plug in 2, so you get 1/9. You're going to plug in 3, so you get 1 over 27. Okay, so these are all my values that I'm going to plot on the graph. Okay, and if you notice, -3, 27 is not going to fit. So we're not gonna plot this guy right here because that's not going to fit, right? Because I don't have my y value, my y-axis doesn't go up to a height of 27, so I'm not going to do that. But I can make it go up to negative. I'm probably not negative. I can make it go up to 9 though, right? So I can put a dot here. And then, oops, I'm sorry, I put it at -1. Okay, it's supposed to be at -2. Sorry about that. So -2 and 9, and -1 and 3, and then 0 and 1, and then 1 and 1/3. So I'm not going to get picky. When you start graphing these things, I'm not going to say, sorry, that's not 1/3. That looks like 1/4. I'm not going to do that, okay? Because my eyes are not even that good to even tell the difference anyway. Okay, so as you can notice, these next 2 dots are just going to get gradually closer and closer to the horizontal asymptote, which is located at y equals 0. Okay, so plotting this is not ideal because it doesn't look very nice. So I'm gonna erase these dots, and I actually pre-planned this graph. I populated the graph on this slide. So let me just unhide this blank graph, and there you can see it. Okay, so when you guys do your graphs, please make sure you guys do a couple of things. You don't necessarily have to show me all the dots. I mean, that's good if you do, but I'm not going to necessarily require it. But I do want you guys to draw the HA, the horizontal asymptote, and I do want you guys to label your y-intercept. Okay, so make sure you guys actually plot the y-intercept dot as well. And if you can, yeah, just draw your curve as nice as possible, which might entail drawing those dots. Yeah, but if you don't want to draw every single one of them because that's kind of a lot, right? That's like 6 dots you got to plot, then draw as many as you need to get a nice feel for the graph as far as the shape. Yeah, because I know how earlier lessons with graphs kind of messed you guys up where the dots didn't really make sense as far as where the graph was. So, like I said, put as many dots as it takes for you to get a feel for what the graph is going to look like. Okay? All right. So, that's it for this graph. Let's move on to the next graph, which is, I think, a logarithmic graph. Okay, so let's just take a look at the logarithm graph. Okay, so this is going to take a little bit more work, as you can see from this next slide already. Okay, so we're going to graph the logarithm of log base 2 of x. Okay, so the technique that I'm going to show you guys to graph this thing is going to be not to graph the log base 2 equation first. You're going to grab that base 2, turn it into an exponential. So you're going to go grab that base 2, turn it into an exponent, which is going to make it as 2 to the power of x. Yeah, and you're going to create a table for 2 to the power of x instead, which is going to seem very much like the previous two problems that we just did. So 2 to the power of x, you're going to plug in -2, -1, 0, 1, 2, 3. And when you plug in those numbers, you're going to get 1/4, 1/2, 1, 2, 4, and 8. Okay, so we're doing exactly what we just did in the previous two problems in step 1 for graphing a logarithmic function. Okay, where you grab the base 2, you turn it into an exponent equation, right? 2 to the power of x. You plug in those random values of x, -2, -1, 0, 1, 2, 3. You get the corresponding y values, and you got your table just like we did the previous two problems. Okay, and here's where it's going to go and do a little bit something different. So you got that table that we just created. Yeah, this table that's on this left side. So you're going to switch the x and the y's. Yeah, and there you're going to say, ooh, that sounds familiar, switching x and y's. And that was actually one of your steps for finding the inverse. And like I said earlier, or maybe I didn't, maybe I said it on a previous version of this video that I recorded, but I erased because I kind of messed up. But exponentials and logarithms are inverse functions of each other. And because they're inverses of each other, switching the x and the y kind of makes sense because they're inverses, and if I switch to x and the y, then I can actually get the dots that I want to plot for the log graph. Okay, so all the numbers that are in the y are going to turn into my x's. All the numbers that are in the x column are going to turn into my y's. Yeah, for the log values. Yeah, the log base 2 values. Okay, so you can see how the x's and y's, they just switch places. It's like I just literally scratched out this y. Oops, let me actually get it into pen mode. In essence, I basically just scratched out this y and I put an x instead. Scratch out this x and put a y instead. And those are my brand new values of x and y for the log base 2 equation. Okay, and then once I got those brand new values, I'm going to plot all these dots. And as you can see, when I plot all the dots, I get the graph of this logarithm base 2. Okay, and notice how it also has an asymptote. It's a vertical asymptote this time though. Yeah, the exponential graph has a horizontal asymptote. The logarithm has a vertical asymptote. So please understand that difference. Okay, and you're gonna label the location of the x-intercept, and pretty much this is done. Okay, so I'm going to show you guys the next slide, and when you guys see the next slide, then hopefully you guys can take a quick screenshot, because I'm not going to spend too much time on this, but it basically is the same exact process that I just showed you, except the only difference is the base value is 1/2. Okay, so since the base value is 1/2, it's just going to do the opposite, right? The last graph, it was going down as you went to the left. This one is going up as you go from right to left. Okay, so it's a little bit different, I guess, characteristics involved. Okay, and it all basically is because the base value is between 0 and 1. Okay, all right, so let's start to get to some live problems. And here we go. Okay, so I'm gonna show you guys how to create tables, because that's probably going to be the part that's the most important. That's going to make or break a problem. If you can't create the table, then yeah, you're not going to do the graph anyway. So our job is to graph this equation called log base 5 of x. So you're going to use that base 5. You're going to create an equation from it. So 5 to the power of x. Okay, and we're going to create a table based on 5 to the power of x. So we're going to use our regular values. -3, 2, 1, 0, 1, 2, 3. And actually, I think we already did create a table of 5 to the power of x. I think that's one of the first problems I showed you guys. So since I'm pretty sure I did that, I'm just going to show you guys what the values are. So these are the corresponding values when I plug in -3, -2, -1, 0, 1, 2, 3. And I get these values right here. Okay. Then I'm going to switch to x and y. So all my x's, right, the -3, -2, -1, 0, 1, 2, 3, they're all going to turn into my y values. So check it out. Yeah. So all my x's turned into the y's. And then all my y's, the 1 over 125, the 1 over 25, the 1 over 5, the 1, the 25 to 25, the 1, the 5, 25, 125. Sorry, tongue twister. They all turn into my x's. Okay, so let me move this table. Come on, how come my pen's not working? There we go. Okay, and then I got my table. So this table right here, yeah, this table right here, oops, let me get it into pen mode. That would be nice. This table right here is the one I want to plot the dots for. Okay, that's the one I want to plot the dots for. Yeah. Okay, so let's check out one more problem. Let's check it out where it's the whole thing from start to finish. So we're gonna make our tables, we're gonna plot our points, and we're gonna get our equation, or get our graph rather, sorry. Okay, so our job is to plot the equation log base 1/3 of x. So the first thing you want to do is you want to grab that base 1/3, turn it into an equation. Yeah, so 1/3 to the power of x. And you're going to plug in -3, -2, -1, 0, 1, 2, 3. And when I do that, okay, come on. Okay, there we go. I'm going to get my table. And this table also looks pretty familiar because I'm pretty sure I did this as the second problem that I showed you guys, right? I used the equation called 1/3 to the power of x, and I got all these exact same values. Okay, so my x column, right? My -3, -2, -1, 0, 1, 2, 3, they're going to all become my y value, my y column on my brand new table, because I'm going to switch to x and y. And then my y column from the previous table, right? The first table I made, the 27, the 9, the 3, the 1, the 1/3, the 1/9, the 127, they're all going to turn into my x's. Okay, so I got this brand new table, and I'm going to plot these dots. Okay, so obviously I can't plot this first guy, right? I cannot plot 27, -3 because my x values don't go that far, so I'm going to ignore that one. And actually, I can't even plot the second one, 9, -2, because my graph only goes up to 5 or 6 on the x-axis, so I can't plot this next guy either. So sometimes this is going to happen, right? You're gonna have all these values that don't fit, and that's fine. Don't worry about it. Yeah, just plot what you can. So I believe I can only plot the bottom 5 coordinates. Yeah, the 3, -1, which will be kind of sort of like right here. Ooh, actually, I put the wrong picture of the graph on here. Sorry about that. I needed to put the other one, but yeah, sorry about that. So let me just unhide this graph, and you guys can see what it's going to look like. Because when I superimpose the picture of a blank graph on this real graph, wait, how come it's not moving away? Okay, I put the wrong blank graph on there. Sorry about that. Okay, but here's the picture that you're going to get. And actually, 9, -2 would have fit because, yeah, I was supposed to have put this graph over the picture in the first place. Yeah, the one that has the y-axis all the way on the left and the x-axis right down the middle. Okay, so 9, -2 would have fit. That would have been probably right around here. Yeah, so it should have fit, but I put the wrong graph over it. Yeah, and then we got 3, -1. That's like right here. And then you got 1, 0, right? And then as you do the 1/3, 1, the 1/9, 2, don't worry about your dot not being exactly at 1/3 or 1/9 or 127, because that's impossible to draw that kind of accuracy with your hands. So don't worry about that kind of stuff. Okay, but that's it. That's it for this lesson. So I hope it made sense. And sorry for the mistake earlier about the blank graph, the wrong one that I put on this slide. But yeah, hopefully you got on. You didn't confuse you too much. But if you did, then just ask me in class. Okay. All right. Take care and good luck on the homework. Bye bye.